Hello, fellow scholars and innovators. This is the third video in my series about using the Unity game design engine and the practice of game design to provide authentic applications of narrative writing skills and language arts skills in general. In the last video, I demonstrated how to create a video game cutscene by outlining how I created the opening cutscene for this medieval Fahrenheit 451 inspired story. I went beyond a simple tutorial, demonstrating how the creation of this opening scene promoted the use of language arts skills, one of which implicates digital technologies. In this video, I will demonstrate how to create a playable portion of the game by writing a C# script. C# is the coding language that the Unity game design engine uses, and, as with all coding languages, C# has a syntactical and grammatical structure that must be understood and applied in order to tell the components within the game to do specific things. This pertains to the third standard for language outlined by the Common Core and New Jersey State Learning Standards for English, as you will be applying knowledge of language to make effective choices to write lines of code so that the game engine can accurately provide instructions to the different elements of your game. As such, there is ample room for teaching coding within the realm of language arts. Before we get into actually writing the code, however, let's first learn how to create a new scene. This first scene is providing the exposition, and whenever I hit play, it will play the animation for the cutscene. So we want to create another scene where we can play a character in this game. And since the animation was applied to the camera, and we do not want the cutscene animation to be copied into the next scene, we will select all of the elements of the game except the camera, copy them, click on File and New Scene, and then paste the elements we just copied into the new scene. This scene will basically follow from the opening, which introduces the conflict between the King of Babel and his subjects, with the king having burned all of the books of spells. I will be adding elements to the backgrounds later to be more befitting of the conflict, as well as the non-playable characters' reactions or the NPCs' reactions to what is supposed to be going on in this particular scene later. Like I said, this video is specifically about applying knowledge of the C# coding language in order to manipulate a playable character. Now I'm going to click on the Knight of Babel, since that will be our playable character. And you're going to want to make sure the character you are making playable has the character controller and a rigid body selected. The character controller will be called in one of the scripts we will be writing and examining for syntactical and grammatical conventions, and the rigid body will have to have uses gravity checked. And I'll explain why after presenting you with a simple script that will make this character move forward and jump. If you don't have those components on the character and you don't know how to add them, you can simply go to the Add Components button on the bottom here and go to Physics, because all physics components will have to do with how the character moves, and select the character controller and rigid body components. Now, even when you're doing this, the language standard L3 is pertinent, as there is some type of linguistic intuitiveness in determining where to look to retrieve and add the components you need for your characters. As I had said before, the character controller and the rigid body both have to do with making the character move and how the character moves. So students may be able to logically deduce that the physics option in the drop-down menu is where the components that will dictate character movements are found. After all, physics is defined as the science of matter in motion, so students can apply their understanding of the word, their knowledge of language essentially, to determine what choices to make to appropriately and effectively convey to the game design engine what it is they want the character to be able to do. You can prompt students to engage in this syllogistic reasoning through your direction and questioning. Once they have their characters laid out on a plane, you can tell them that they want their character to be able to move when certain key codes are entered, and ask them to determine where they would go to add those components, and which option in the drop-down menu would allow them to achieve the desired outcome, and why they thought that option would help them achieve said outcome. Now to create a script. Select the appropriate folder under the Projects tab in which to create your C# script. As for myself, I placed all of the scripts in the prefabs folder, but you may use your own discretion in determining which folder will house your script for this particular character. Now, I already have this script that I wrote, so I will copy and paste it into Unity's text edit. Please keep in mind that the public class name, which I am currently renaming as sample for video, has to match the file name precisely. As such, I am now changing the file name as well. Let us now take a look at the scripts. So this is the code that I wrote to get my character to jump, fall back to the ground after jumping, and move forward. I also have a line of code to make the Knight of Babel disappear, but I used my knowledge of the conventions of the coding language to make the compiler ignore that line of code. Take a moment to see if you can apply your knowledge of language to determine what lines of code are responsible for each of those three motions. Also note how there are certain punctuation marks that repeat. This, once more, is because the coding language has its own conventions that allow the compiler to understand and subsequently provide instructions for the different elements of your game. Once again, see if you can apply your knowledge of language to determine why the semicolons are used throughout the code. Hint, you may want to consider why there is no semicolon that follows each line of code with the word if, but there is one following lines of code immediately subsequent to the line containing the word if. If you haven't figured it out yet, it will all make sense in a moment, but let's take a look at the code line by line. Now, as this is an introduction to the coding language used by Unity and how it relates to the language standards outlined by Common Core and the New Jersey State Learning Standards, I'm going to ignore these three lines of code, which are namespaces. Instead, I'm going to focus on the simple instructions that I am providing to the Knight of Babel character, which all come after the void start. And for simplicity's sake, and because I want to make this as accessible as possible to the layman, I will not delve too deeply into what void start and void update mean. Suffice it to say, the void start and void update are spaces in which I can write lines of code to tell my character what to do. Now, the first line of code was just something simple that I had experimented with. It reads destroy, and in parentheses it says game object. What that means is that when I hit play, I want the game object to which this script is attached to be destroyed, so it will essentially disappear. In this case, the game object that the script is attached to is the Knight of Babel character, and so you know, you can attach scripts to characters by simply dragging and dropping the script to the game object's name in the hierarchy. Now that we know what the line of code the compiler is ignoring does, let us move on to the line of code that says rb equals get component rigid body. And rigid body was a variable that we placed after the initial curly brackets after the list of namespaces. There will be more on this in a subsequent video. But in any case, of the three things that I mentioned this code would make my character do, jump, fall back to the ground after jumping, or moving forward, which do you think will result from this line of code? Consider that when we added the rigid body component, we checked off the uses gravity box. If you applied your knowledge of the word gravity, you may have concluded that it would make the character fall back to the ground after jumping, and you would be correct. As such, if we would not have clicked on the uses gravity checkbox, this would happen. Notice how he does not stop moving up on the y-axis. Also note that is kinematic under the rigid body would have to be unchecked for this particular code to work. In any case, the rigid body component allows the game object to which it is attached to utilize various physics mechanics. In other words, it gets your character to move around. That is why I write scripts telling the compiler to access the rigid body. But if I told the compiler to ignore this with the 2 forward slashes, I'm pressing the keys U and space here, and nothing's happening. With that said, consider this question. After the compiler accesses the rigid body to allow for the Knight of Babel character to be able to move, which key, the U or the spacebar, causes the Knight of Babel to jump? You can apply your knowledge of language to determine this. If you answer the U key, you would be correct, and you may have deduced that from these 2 lines of code, which basically provide a condition in the first line and what the character will do if that condition is fulfilled in the second line. Notice how there is no semicolon after the first line. Why do you suppose this is? If you apply your knowledge of language, you might deduce that, like subordinating conjunctions in standard English grammar, this line cannot stand alone as a statement. It merely provides a condition. So the code reads if, and then there's a space, and then an open parentheses, and then it says inputs.getKey down. So that means if you are pressing a certain key or button, because if you are pressing a button it goes down, something is going to happen. Of course, you have to tell the compiler to which key you are referring, and you do that by creating another parenthetical, and you type keycode.u, and then close the inside and outside parentheses. This tells the compiler that the key to which you were referring to was the U button. So essentially, this line of code means if the U button is pressed. So that is the condition. Now we need to tell the compiler what we want the Knight of Babel to do when the U key is being pressed. And we do this in the next line. And we will have to offset that line with curly brackets. Then we type rb.addForce, open parentheses, vector3.up times 700, close parentheses. Remember that in the void start section, we indicated that RB would prompt the compiler to access the rigid body, which causes the character to react to physics mechanics. We then have to add force. So think about what happens to you if force is applied to you. You would be moving in the direction that the force is moving you, and we want this character to move upwards within this 3-dimensional plane, and that's what vector 3 means, a 3D plane. And times 700 just indicates the speed at which we want the character to move in an upward direction. Notice also how this completes the statement beginning with the if condition from the previous line. That is why this line is ended with a semicolon. In the C# coding language, semicolons follow completed statements. Now let's look at the next 2 lines of code, the second of which applies a velocity to the rigid body. In that first line, we have the same thing as before, a condition. However, this time the value after the key code and the period is changed to space. So we are giving the character another key command. When the space key is pressed, we will give the Knight of Babel a velocity. And velocity, meaning the speed of something in a particular direction, will allow the Knight of Babel to move in a specified direction. Though this can also be used to get the character to move upward, we are going to use velocity to make the character move forward on the 3D plane, so along the z-axis when the space button is pressed. And the times 20f once more refers to the speed at which the character will be moving. The problem here is that we need the compiler to know that we want the character to gain velocity in the forward direction only as the space button is being pressed. We want to stop once we stop pressing the space button, so we are going to provide the compiler with another condition that will provide directions as to what the Knight of Babel will do once we have stopped pressing the space button. And this first line of the statement logically makes sense. If inputs.getKeyDown refers to a particular key on the keyboard being pressed, then inputs.getKeyUp would obviously refer to a particular key no longer being pressed. And we once again indicate what key that is by creating a parenthetical within the parentheses and typing keycode.space to tell the compiler that we are referring to the space button, and then close both parentheses. Now we want to tell the compiler that if the space key is not being pressed, the Knight of Babel will stop moving. And we don't need to get rid of the velocity to accomplish this. We can instead keep that line of code for velocity from before, but we just change the speed to 0. After all, if something is moving with 0 speed, it's not moving. And after that, we have a character that can move forward, stop, and jump. There is one more thing I must go over regarding the grammatical conventions applied in this bit of code that I wrote, and that is the use of the curly brackets. In an attempt to explain this so that it is understandable to the layman, I will say that brackets are used to denote the beginning and ending of different parts of your code. For instance, in the part of the code where I want the character to jump, that is the only thing I want to happen when the U key is pressed. I may be able to have multiple statements telling the compiler to make the Knight of Babel do several things, such as switch animations while moving upward, but for now, to keep it simple, I only wanted one thing to happen when this button is pressed, so I offset that one thing with brackets. If there were two things I wanted to happen when U is pressed, I would add one additional statement within that same pair of brackets. If you are writing a line of code and there are multiple things you want your character to do, you will likely have parts of code within parts of code. So you will have brackets within brackets, as you see in the code that I wrote. Take this part of the code, which features two if statements, for instance. The condition that I am presenting is one part of my code. It is a condition. After I introduce that condition, I want to introduce the outcomes of that condition. So I will denote that by opening up another set of brackets. Since there is only one outcome, I will close this set of brackets that I had opened within this condition. And if there were no other conditions that would prompt any additional outcomes, I would have closed the outside brackets for the condition as well. But because I want the Knight of Babel to perform another action when the space key is not pressed, I keep the curly brackets for the condition open and introduce another if statement followed by another opening curly bracket, the outcome, and then another closing curly bracket. And then I close the outside brackets for the condition because I have no more conditions to introduce. When you look at the code in its entirety, you will see the curly brackets being used this way throughout. Essentially, your code will have to have an equal number of opening and closing curly brackets. Now, you may have noticed that the movement of the character is not as dynamic and fluid as what you saw at the beginning of this video, and that is because there is more complex code that was used to accomplish that, and more nuanced knowledge of the coding language is required to write and understand that code. And because this may have already been a lot to absorb, that code, and any additional associated conventions of the C# coding language will be reviewed in the following video. Just bear in mind that this project will be heavy on the coding aspects, and the act of coding does not have to be relegated to math and science. Because coding languages have their own grammatical and syntactical conventions that must be applied appropriately and consistently to communicate to the compiler what instructions to provide, such an activity complements the language arts subject as well, and that is what I intended for you to glean from this video.